So on to problem number 3 of the 2006 MIT Integration Bee Quarterfinals, quarterfinal number 1. Very, very interesting problem, a problem that tripped both contestants. The definite integral of x squared minus 2 over x to the power 4 plus 5x squared plus 4 close bracket times the arctangent of x squared plus 2 over x. So let's see how we may be able to solve this problem. First thing I would do is I look at the denominator and pull out the x squared, and I'm trying to see that because I look at x squared minus 2 and I see the derivative of the argument of the arctangent function. So when I pull the x squared out, and now I allow it to interact with the numerator so that we have x squared minus 2 over x squared, what comes out of it is very interesting. It actually becomes the derivative of whatever we have under the arctangent function. So x squared minus 2 over x squared becomes 1 minus 2 over x squared, right? And that is the derivative of whatever is in the arctangent side. And when we also look at what remains, x squared plus 5 plus 4 over x squared, that's the same as x squared plus 2 over x squared plus 1. So now let's go ahead and substitute of the complicated part, and that's the arctangent of x squared plus 2 over x. So let u be equal to arctangent of x squared plus 2 over x. That means that the tangent of u now allows you to access the x squared plus 2 over x. And therefore the derivative of tangent of u is sec squared u du dx being equal to 1 minus 2 over x squared. And that's exactly what we have in the numerator of our integrand. And so going forward, we can now say sec squared du dx equals to, if we now express it in form of a common denominator, x squared minus 2 over x squared. So sec squared u du can be used to substitute of whatever is in the numerator here. That is x squared minus u minus 2 over x squared times dx. Let's now transform this into the u domain. We know whatever is in the numerator, x squared minus 2 over x squared times dx, is the same as sec squared u du, and x squared plus 2 over x is the same as tangent of u, and arctangent x squared plus of arctangent of x squared plus 2 over x is the same as u. So that now compresses this integral into this simple integral. The tangent squared u plus 1 is the same as sec squared u. So that now allows us to have two functions that are similar both in the numerator and denominator that can cancel out. So sec squared u in the numerator and sec squared u in the denominator will cancel out, and our integral now simplifies to a du over, 1 over u. And when we integrate that, we have the natural logarithm of u plus the integration constant. And we remember that u is the arctangent of x squared plus 2 over x. Therefore, our final integral of x squared minus 2 over, open bracket, x to the power 4 plus 5x squared plus 4 times the arctangent of x squared plus 2 over x is the natural logarithm of the arctangent of x squared plus 2 over x, plus the integration constant, obviously. We don't want to forget that. So, and that is how one would simply solve that problem that looks complicated, but it's just something that we always say it is good to be lazy sometimes and observe the patterns within your integrand to be able to exploit them. So until next time, bye-bye.